Okay, here we have a chance for you to practice your radioactive decay equations. Okay, so figuring out what is going on with the numbers in these elements. We've got some fictitious elements, W, X, Y, and Z, and they're emitting different types of radiation, gamma, beta, and alpha radiation, and it's changing into different elements. All you have to do in the GCSE is to figure out what numbers you're left with after each of these emissions. So what I want you to do is pause the video, write this down and try and figure out the numbers that should be going in where the green question marks are. Okay, so pause the video now. Pause it. Did you pause it? Okay. We'll assume you paused it and we'll work through the solutions. So, element W, atomic number 40, mass number 96, emits some gamma radiation. Now, gamma radiation, as we should know by now, is just electromagnetic radiation. It has no mass. So in actual fact, the numbers will remain unchanged. Gamma is a nice easy one. So we've still got the same numbers. So technically this should still be the same element. Okay, it's still got the same number of protons. Now, element here emits a beta particle, beta radiation. This occurs when a neutron emits a proton. A neutron turns into a proton and an electron. That's essentially what a beta particle is. It's an electron. So when this happens, the atomic number goes up by 1, therefore we have a new element, and the mass number remains the same. So 96 for a mass number, 41 for the atomic number. Now, this element is still unstable, this isotope is still unstable, so it emits an alpha particle. An alpha particle is basically a helium nucleus, helium being this, but it doesn't have any electrons, so it's very, very charged, okay, as a positive charge, very dangerous alpha particles. So, an alpha particle, when it is emitted, the atomic number goes down by 2, so this will be 39, and the mass number goes down by 4, so this will be 92. So, in each of these isotopes is unstable, and it will emit a certain type of radiation, so it becomes more stable. So the bottom line is gamma radiation, we don't have to change the numbers at all. Beta radiation, the atomic number goes up by 1 because 41 plus minus 1 is 40, and we've basically added a proton but removed a neutron, so the mass number will stay the same because the mass number is neutrons plus protons, but because we've got another proton, the atomic number goes up, so this will go from 40 up on to 41, and then when we have alpha emission, we've got a neutron, 2 neutrons, 2 protons removed. This is a 92, so you take 4 away from the top, you take 2 away from the atomic number, and we're left with 39. How'd you do?